So it's lesson 1 of our mean stack class. We've talked a bit about blocking versus non-blocking code. So we're going to try a similar example to the one described in the Code School video. So we're going to make a couple of text files. We're going to make them different lengths, and then we're going to try reading and printing out the contents of those files. We'll try it first blocking, and then we'll try it non-blocking. So I'm going to make a new file here. So I'm just going to right click and choose new file. And we'll make these text files. So I'm going to call this one food.txt. Doesn't really matter what you call it. So give this one an extension because otherwise it won't assign any extensions. So we'll make food.txt. Okay, now what are you eating? Cookies? Are you eating, what are those, cookies? All right, so let's make a list of what we've eaten today. What have you eaten today? Besides cookies. Okay, what else have we eaten today? AJ, what have you eaten today? I had toast. Well, we'll come back to that. We're going to make a drinks file next. So what else have we eaten today? Sandwich. Okay. Like right out of the jar? Do you use a spoon or just right with the fingers? Just with a knife. Okay. I had a couple of clementines with my breakfast because it is the season. Yes. Yeah, it should be TXT. Sure. So scrambled eggs. I had some cheese. Anything else? Let's add a couple more things. Maybe 2 or 3 more. Because we want the list to be very different lengths. We already got sandwich. Okay, that's probably good. Doesn't really matter what you put in your list. We just want to have a list, a significant list. I'd say at least a dozen things. No, I did not. I didn't spell it correctly. Pardon? Right. Yeah. All right, so there's our food list. Let's make a second text file. So new file, drinks.txt. What are we drinking today? What else? Okay, I see Brad's got water. Linda's got fizzy water. Of course it is. Linda's fancy. Okay. All right, so we'll maybe stop there. We'll make our list shorter. That's right. Okay, so 2 lists. So we want to read these files. We want to build a node file that reads and prints out the contents of each file. Right? That's what was happening here. 2 files that are both getting read and getting printed. So let's make a new JavaScript file, which we'll call this one blocking. So we want to read and display the contents of both files. So in order to do this, we don't need the HTTP module. We're not going to use a web server, but we're going to need another built-in module from Node, which is designed for reading from files from the file system. So we need to be able to open and process the contents of these text files. So we're going to include Node's file system library to read the text files. So we're going to require, and the library is called FS. So that's used for interacting with files on the file system for reading or writing files. So we're going to require it. So first, our code is going to be synchronous or blocking. So I'm going to create a variable called food, and we're going to assign the variable equal to this file system library has a method called read file sync. So read the file in a way that it blocks. Nothing else happens while this function is run until it's complete. So we want to read the file called food.txt. We also have to provide the encoding type to this method, so we'll just say UTF-8. So we'll read and display food list. So we're going to display, so when we read this file, that will populate our food variable with the contents of our text file, our 15 items. And then after that's done, we'll print out a message that says hello food. We then want to do the exact same thing with the other file, with the drink file. So we're going to create a drink variable. We'll call read file sync second time to open the next file, and then we'll log out the contents of our drink file, and then we'll print a message when we're done. Exact same thing. So this time we're going to bring drinks.txt. So there's our file. So we're going to have 4 different things display in our console when we do this. We'll have 2 messages and then 2 lists. If we run this file, in what order are these things going to get displayed? Okay, and what about the 2 messages? Where in the sequence will those get displayed? Okay, but then where do they go in relation to the 2 lists, right? We have a list of 15 food items. We have a message about food. We have a list of 5 drinks, and we have a message about drinks. So what order will those get displayed in? Yeah, in that order. So it should display 15 food items. It should then display our first message. Then it should display our list of drinks. And finally, a message about our drinks. So if we want to run this to try it out, we can just run the node command and run blocking. Our console should then, we'll print out these 4 things and we'll check what order they happen in. just a moment. So first we get our list of food. And we get a hello food message. We get our shorter list of drinks. And we get our hello drinks. So now it's correct. This happens basically in the order we wrote the code. One thing happens. So nothing happens until this list of 15 food items. Nothing happens until that list of 15 food items is read out and printed. So that blocks or stops everything. The code happens sequentially in this case. So if you're getting an error, then Brad, something's not named correctly. So in these read file sync methods, these file names, food.txt and drinks.txt, they have to match the text file names exactly. So check the names carefully. Blair? Yes, that's a good question. Right. So after banana and after apple juice, I suspect, because I have a blank, you can actually see from the line numbers, because I hit enter after banana, it prints a blank line. If I take that out, that's interesting. No, my code editor, so I've taken it out, so it says I have 15 lines, yet if I save my file, it keeps, my code editor's putting that blank line in. That's why. And same here in drinks, it shows I've got this blank line.
I went over all the instances and for drinks.
So for our next trick, we're going to rewrite this code, but we're going to use non-blocking code. So we're going to create a nonblocking.js file. We're going to read both files, but this time we're going to use callbacks. So the code will run asynchronously. And we can compare the results. Now, from a logic perspective, it probably makes sense to write the file this way. But we want to compare what happens if we use asynchronous code instead. So let's make another JavaScript file, which we'll call nonblocking. So again, we'll link to Node's file system library. So we'll read and display food list. So this time, instead of calling read file sync, which is synchronous blocking code, we're just going to call read file. So notice the base, by default, Node is designed to run asynchronous. So the method called read file is asynchronous. If we want synchronous code, we explicitly have to call the version that has async in the name. So we're going to read food.txt. We'll set our encoding. And now we're going to add a third parameter, which is our callback. So when we try to read our file, we're going to get back one of two things. What are the two possibilities of what we might get back when we try to open and read that file? Yeah, so either we get back the list of food, and if we don't get back the list of food, what are we probably going to get instead? Because we know that file exists, and we know there's content in it. Yeah, so we'll get some kind of error. So we're going to have two parameters in our callback. The first one is an error, and the second one is our list of food. I'm just giving these are just variables I'm naming. So when we try this operation, it's going to return one of two things. So we're going to get one or the other. So here is our callback. So when this is done, we are going to log it. We won't worry about the error handling part for now. So then we'll display our hello food message. And then we want to do the same thing with drinks. Let's read the file asynchronously. So we're going to call read file with drinks.txt. And again, we'll get back either an error or a list of drinks in callback function. So there's our complete file. So now I'm going to ask the same question I asked you before we ran the synchronous version. In what order are these four things going to get displayed to the console? We have two messages, a list of 15 items, and a list of 5 items. Okay, so, and which list will be first, food or drinks? So list of food, list of drinks, hello food, hello drinks. Okay, Nat, what's your prediction? Okay, so you're saying, so almost the complete opposite. That we'll get line 9 and line 16 being displayed first, the list of drinks. And why are you predicting, why do you think drinks, the list of drinks will be displayed before the list of food? Okay, any other predictions? So you think it might give us an error because of this? All right, well, all kinds of possibilities, aren't there? So let's try to run non-blocking, see what happens. So what did we get? So we got our messages first. No, here's my food. And here's the drinks. So why do these happen? Why does hello food and hello drinks happen first? Right. It starts reading the file, but obviously this takes some time to read the file and print the contents. So the code continues execution. It prints the heading. This is still running. And then in parallel, it's also opening and reading the drinks file. That also takes time. So while that's running, it can then print this header. So this one obviously happens fast enough that it still completes before the drinks does. Okay, there's a few other ways. Let's see what happens. What if we move this inside of here? So start reading food, and while we're processing it, also do the drinks. Let's try that and see if we get a different result. So I'm just going to drag this for now. I may not leave it here. So start on the food, but let's see what happens if we try it this way. So I just hit the up arrow in my terminal. It'll repeat my last command again. We actually get same result. I'm just going to undo that for a minute. Whoops. So the question in my mind is, food is 3 times as long as the drinks, yet it still gets displayed first. I wonder just how big the food file has to be before the drinks show up first. Well, there's a simple way we can test it. I'll copy those 15. What happens if it's now 6 times as long? Just how big does that food file have to be for our drinks to show up again? So I'll try it again. Our drinks are still at the bottom. We'll make our food really big. No, you don't have to. We're just playing with it.
I think the most time is spent on the week and the last file is not enough. So you should try like a little bit time in food.
Like put in a set, do a set timeout.
Yeah. Like 3 seconds there, 1 second,
Yeah, so I think if we call set timeout, we can try that. Let's see. Oh, it's got to be a function. I think it'd have to be like this. So we'll wait 5 seconds. Let's try that. Even waiting 5 seconds, which you didn't do. Yes, thank you. I'm printing it out and waiting 5 seconds. Yes, that doesn't help. Okay. Good suggestion, yes. I may have to go inside. Yeah. I think it has to go in there. Eventually, we'll get our drinks to go first. That's clearly not 5 seconds. Oh, yes, it is. Sorry, there. Let me run that again. You can see in the terminal. Maybe I'll clear out my terminal. So CLS will clear everything. So I'll run it one more time. So it prints the drinks and now it waits 5 seconds. And then it prints the food. So by default, everything we do in Node is non-blocking and asynchronous. So this callback structure automatically makes our code run asynchronously. So we can write blocking code like we did in our blocking.js file by explicitly, for example, calling a synchronous method. So do this and don't do anything else until this is finished. But the callback says, start this process and go do something else and then come back here when you're finished. So we can do multiple things at once. And then if we wanted to, we could, if we wanted to check for errors, we could handle any error if we needed to. So that was most of what I wanted to try for today. I will put the code up on Git in a minute. I'm just going to draw your attention. I do actually, unlike most courses, I do have a few slides for this class. So I put a slide deck up here that kind of goes over a number of things we did today. So they're here. A lot of what was in the discussion forum, the questions I asked, a lot of that stuff is in here as well. But there are one or two things I just want to touch on quickly. And then we will go. I think everybody knows what MVC and the mean stack is now. So here's kind of a visual of how this all fits together. I meant to pull this up earlier. So just for the visual learners. So Node sits in the middle, right? That runs all our backend logic. All of that code is our Node code. Eventually, we'll have MongoDB on the backend. We'll get into that probably in about 3 or 4 weeks. So that'll be a replacement, but not an exact substitute for when we've used MySQL and SQL Server in the past. But the structure of Mongo is really different. It's a non-relational database, which also is something different than what you're used to. It'll take a little while to get our heads around it, because again, a lot of the rules we taught you guys in relational database, we're going to break a lot of those rules when it comes to using NoSQL. Who was your database teacher? Was it Matt? Jonathan for relational database. Okay. So we'll use Mongo. We're going to use Express instead of that HTTP library. Express will handle the server end of things in terms of setting up the server and handling requests. And then later on, we'll build a dynamic front end with Angular. So Angular allows things to update on our page in real time without the page having to reload, which is pretty useful. So for example, we add something to a database, we can repopulate a list without our page refreshing, which gives a really fast and good user experience. So that's how all the pieces are going to fit together. So a lot of this stuff I think we actually went over, but this is here for you as a reference. So either next week, is it next week? The other thing we're going to talk about next week, and someone mentioned the lesson, so we're going to deal with NPM. Who mentioned NPM in the discussion board? Somebody did in your post. I think it was Kyle, who's now left. So NPM is Node Package Manager. So we're going to get into that next week. NPM is a really critical tool. It's kind of, well, we've used, if you remember, the NuGet Package Manager in ASP.NET. NuGet is actually Microsoft's version of NPM. So NPM was around first, and it's older. So it's a library where we can find third-party tools and libraries to add into our Node applications to extend their functionality. But so there's some cool things about it. There's also a couple of huge caveats with working with NPM. We'll talk about that next week, the 17 lines of code that broke the internet. What happens when millions of developers use one NPM package and that developer pulls his package? We'll talk about that. That's fun. Okay, so these slides are here. We will have also give you your first lab. We'll give that out next week. It'll be due the following Friday. Okay, I will push everything up to GitHub. So the files we did today. So if you don't have them running, make sure you have them working. Try them out. It won't take you very long. We only did maybe 20 lines of code the whole class. Okay, make sure you play around with it and you start to get comfortable with your environment and running your files. Okay, that's all for this week. I will see most of you on Monday, and the rest of you I'll see next Tuesday. Have a good week.